Cool fact number 2. You can look at a polynomial and by identifying the degree of the polynomial, you can know about the behavior of the graph in terms of its turning points. So first of all, I want you to look over here and understand what a turning point is. So a turning point happens when the graph changes from going down, it turns around, and now it starts going up. And when we talk about turning points, we always read the graph from left to right. So you always want to start on the left-hand side. So it was, as we start over here on the left-hand side, we go down, 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 we turn around, we go up, up, up. That's a turning point. We'll learn a more mathematical term for it later. It's a minimum or a relative minimum and a maximum, relative maximum. I think it's in the next lesson. But turning points are what we're counting right here. So here we see right here we have 2 turning points. And here we have 1, 2, 3 turning points. 3 turning points. Okay, be careful on these right here. These are kind of weird looking because remember I said a turning point happens when you change from either going down to going up or when you change from going up like we're doing right here. We're going up, we're going up, we're going up, we're changing, now we're coming down, we're coming down, we're coming down. So this doesn't happen right here. We're going up, we're going up, we're not going up as fast, but we're still going up. Okay, so this one, even though it has a little wiggle right there, it's not considered a turning point because we continued to go up as we moved to the left. Same thing is happening right here. We got a little wiggle going on, but it's not changing. We're going up the whole time. We're going up, we're going up, we're going up. Now we're coming down. So this one right here only has 1 turning point. Okay, so now that you know what a turning point is, what is it about the equation of the polynomial that's going to tell you? So you look at the polynomial, the degree of the polynomial, and whatever the degree of the polynomial is, you take away 1 number from that. So the degree of this polynomial is 3. That means that the graph of this polynomial can have at most 2 turning points. So the greatest number of possible turning points is going to be n minus 1, where n is the degree of the polynomial. So you look at the equation, you find the degree of the polynomial, take 1 away from that number, and that's the number of turning points. So when you're looking at this problem right here and you see that it has 2 turning points, okay, that means that 2 is 1 less than 3. So this one has to be at least a 3rd degree polynomial. Now, we know by looking at the end behavior, the fact that the end behavior is different, that this has to be an odd degree polynomial. So it has to be at most a 3rd degree polynomial, but it could be a 5th or a 7th or whatever, because just because this is a 3rd degree polynomial doesn't mean it has to have 2 turning points, because this right here is a 3rd degree polynomial. I can show you over here where I graphed it. See, here is the 3rd degree polynomial that I graphed. That's it. That's a 3rd degree polynomial, but so is this one. That's a 3rd degree polynomial too, and it doesn't have any turning points. So the point I'm trying to make is just because you know it's a 3rd degree polynomial does not guarantee that you'll have 2 turning points. But if you see 2 turning points, it has to be at least a 3rd degree polynomial. I hope that helps.